Alright, this is the last problem. There's a typo in this. There should be f of x equals x squared minus 1 over x. Alright, let's look at this. We're doing a basic curve sketch. We're going to do a detailed curve sketch. We're looking for vertical asymptotes. Vertical asymptotes generally are where the denominator equals 0. You want to make sure it's either going to a positive infinity or negative infinity. What do I mean by that? I'm going to look at x approaches 0 from the right. Of this function, what happens when I approach 0 from the right? This is basically 0. I'm subtracting 1 from it, so it's going to be negative. And the denominator approaching 0 from the right is going to be positive, but it's going to 0. Remember, when the numerator is going to a number and the denominator is going to 0, that whole ratio is going to infinity, either positive or negative infinity. The denominator is going to be positive because it's right of 0, but the numerator is going to be negative because of that negative 1. So this is approaching negative infinity from the right. From the left, we got denominator going to 0 from the left. This time the denominator is also negative, but the numerator is behaving the same way as it did in the previous one. So 0 minus 1, that's a negative, or something close to whatever. 0 minus 1 is negative, so negative over negative giving us positive infinity. So we definitely have a vertical asymptote at x equals 0. Alright, is there a horizontal asymptote? Well, the degree of the numerator is higher than the degree of the denominator, so there is no horizontal asymptote. Alright, is there anything else? Oh, let's look for zeros. The zeros occur when, in a fraction, the zeros occur when the numerator equals 0. We set that equal to 0. We get, set the numerator equals 0. I just said that. So that's going to be x equals plus or minus 1. Okay. That's not surprising, I guess. Alright, moving on. Let's take the derivative and see how the slopes are behaving. So here, take the denominator up, take the derivative of the numerator, minus derivative of the denominator, which is 1, times the numerator, all over denominator squared. That's going to give us 2x squared minus x squared. Minus and minus is a plus. So we got x squared plus 1 over x squared. So critical values come from the derivative being undefined, or where the derivative equals 0. Undefined values would be x equals 0, but it's all x equals 0. There's also something else going on x equals 0, so it's not a critical value. It's x equals 0 is not in the domain of the original function, so it's not a critical value. However, we will look at it because we need points of discontinuity can be a break in the sign, SIGN, of the derivative. Like it could change from positive to negative. Numerator is x squared plus 1, and that's never equal to 0, so nothing's coming from our numerator. Looking at the sign term for the derivative, look at this. The numerator and denominator both have squares for their x, so that means the signs are positive. So no sign changes there. Alright, so looking at the graph, let's see what we got. We know it crosses at negative 1 and positive 1. We know it's going to go to positive infinity as x approaches 0 from the left. So it's positive infinity. And our derivative shows that it's constantly increasing. Okay? Wow, not very interesting. And as x goes to, we didn't look at what happens. Okay, so it's constantly increasing. Alright, so something looks like this. Alright, we should probably look at what happens as x goes to infinity and negative infinity. What does that mean? I want to look at the limit as x goes to negative infinity, since we have it drawn over here. X squared minus 1 over x. So we're looking at negative infinity. So the numerator, when we put a big negative number in there, turns into positive. But it's going to be positive divided by negative, so it's going to be negative. So this is approaching negative infinity. So it's going to just keep going that way. And looking at positive infinity, positive over positive is going to be positive infinity. So it's going to be increasing like that. Alright, So that's our graph. Okay, just to verify why I decided this or how I concluded that. Remember, we took the limit as x approaches 0 from the right. It went to negative infinity, and that's where we are. Also, to confirm, it's constantly increasing. This is increasing and increasing. Okay, that's it.